Hello, everyone. Thanks for joining and for clicking on this. This is, day 42 of learning Houdini, of Let's Learn Houdini. We are attending DoubleJump Academy's workshop, Houdini for Games in Unreal Engine. If you're curious about that one, link is in the description. And if you want 20%, I also included the discount code with that as well. Otherwise, if you're watching this on a stream, stick around. You'll get to see the discount code in one of the overlays. And yeah, it's not that hard to see. It's actually quite simple, and I'm sure you will find it. Okay, everyone, now we will start working on the pipes again and see where we could improve this thing. Where can we push that thing further? Well, first of all, I could see that this here is out of line, right? And that could be because we scaled them down using the centroid, which, it didn't like as much. Fine, let's try to fix that. I'm not sure if you guys can see this. Y'all can see this. That's awesome. I'm trying to fix it here, and so let's get into it. Let's work here on this panel because everybody can see it, including the people on Insta as well. All right, so let's see how we could improve that. We will go into the files themselves, which we're not allowed to for some reason. Actually we are. Okay, then this is a bit too... Which one are we in? We're in the... Okay, we need one up, and here are the files. And let's see, transform from centroid, and then we need another transform. This is the bend one. That's the one we need to work with. So let's get to the orientation and click. I asked in a lot of servers, some people said make a proxy or split parts or cache it, but I was really confused. How can Blender run a model, have 14 million polygon, but Houdini can't? That confuses me. It could be due to the fact that Houdini works differently with models. So if I may show you, like, here's the thing with Houdini. You have points, and then you have primitives, and then you have vertices, and then you have polygons. So it's not only about the polygons and not only about the vertex count, but also about those. What you work with in Houdini mostly is primitives and points. That could be the reason why it's struggling with it a little bit, but I'm not an expert. What are you trying to do with it? Anyway, what's your main goal? I'm just trying to ask. Okay, so yeah, we need to lock those. Actually, let's do that. Let's freeze them. And why do we freeze them, you ask? Well, we freeze them because if I were to give this file to someone else to look at it, I would need to freeze those so they are inside the file of the generator. And so when I gave this to Grayson yesterday, he was not able to look into it because, I did not freeze those, and now I did, so I will just add a new version here and save it, and these are frozen now, so they would exist inside of the Houdini file. So if we open that Houdini file from another PC, hopefully they will be able to to get those files with the actual file. And just to see if there are any difference with the sizes, it's much bigger. It's a 7 megabyte now instead of 3 megabytes. So I will save that. I actually send it to Grayson right now. Before I forget, I will continue from the transformer orientate, or actually the scale. I mean, I could add just another transform at the end, so we don't have a lot of headache. One more would do. Click on the output, the general output of the pipes, and now click here and then click again. We're doing a lot of clicks. Why? Well, because we need to be able to control this while seeing it here. So yeah, I can see that translate needs some love here. So what is this one doing? What is it doing? What is happening here? That's a weird translation there we're adding. Because we're adding it on one of them. Correct, yeah. Okay, so 0.01 And let's get this thing to fit in the pipe, hopefully. That is fitting. Okay, the next step is maybe here. Let's see if we're lucky. Not. The next step then is here, and let's make it fit into the other pipe. And that is how we manually make them, yeah, fit each other. Good. And now we have the bends basically generating accordingly. And now I could save that file and give it back to Grayson, and which is the mentor of the course. All right, the files are frozen now. And I fixed one more thing. I fixed minor things. Hope this helps. Hope this helps. And let me know if there is anything else. If there's any other problem. Any other problems? Problems with the file? The file, I am always eager to learn. New things. All right. Good. Yeah, that's sent now. Let's keep it up then. The generation looks fine. But we noticed last time that the moment I start playing with the scale, it will start doing those weird things. All right. So mainly, so 0.5 looks totally fine. And then the moment we go to 0.7, it will start creating these weird gray things. I noticed, so I'll just add some context. I noticed the issue of degeneration happens when the scale is above 0.6, and it starts creating a weird kiwi colored pipes. Okay. And yeah, it's this thing. It's weird. It's yellow and green at the same time, and it has no point to connect to. Okay, and one more screenshot of the 0.7 here. Yeah, basically that's just to describe the problem right now. And yeah, okay, let's keep it going. Whenever it's above 0.5, we're getting these issues, and that's fine. I will today, as I said, as I promised, and we also get these weird things. Okay. All right, let me just document that as well. The corners are also intersecting due to the curves being separated, and a fuse would break it. A fuse would break everything. Will break everything. Everything. Okay. So due to the curves of the intersecting, I think it's due to the curves of the find shortest path being are still being separated. Let me kill this bug. All right, are still being separated, and the fuse will break everything. All right. Now I'm gonna just include that. Good, and then we can keep going. Actually, I'm just gonna add one line, just to document, just in order to document the issue I'm having at the moment. Okay, I know that. Okay, and then it goes like this. Good. Let's keep going. This looks good though. Like it's okay-ish. This is weird here, and we could fix that if we want to. Um, it's not a hard fix, but this should not even happen anyway. Just trying to look because this is made to fit this type of thing, but not much this one. For now, I'll just accept it and we'll go with the course. I can't be spending much more time, fixing things the whole time. So yeah, let's give it going. Recording. Okay, so we'll start with the vellum simulation now. We'll probably need to go a hierarchy upwards, and yeah, we'll go to our basic structure here. And yeah, let's get that down there and this one down here. We'll create a new subnetwork. I think we could just create a subnetwork, and this one will be a simulation network. I think my simulation color is a red. Simulation network. Oh, sorry. Simulation vellum. For now, it will be called vellum wires. Good. Wires or cables, whatever. Both are fine, and let's get our colors back. And I just realized yesterday that I could make them smaller, which is awesome. Okay, red for sim, that works for me. And we need two inputs. One will be the cables, so the wires, the curves, the whatever, the spline. So we'll take that, put it in here, and the second one will be our copy to points, which would be our actual geometry. Awesome, yeah. So we'll call each one differently, and let's get a null here, and yeah, copy it inside. Let's put it inside. This will be our copy to point, and this will be our what exactly? The spline. Okay. So spline, we'll keep it white, I guess. That's fine. And yeah, let's put them next to each other. Upwards, Shift S for better curves, and these will be here on the side. They're not being used, so black. Okay. And yeah, so let's start. Let's add a null here. Boom. And let's get this thing to have the same color. And we'll call it out, actually in. And it will be called geometry, final geometry, right? Final geo. That's good. And here we'll add a null. And this one will be called the curves. Okay. And yeah. So in curves. Good. Or what else? I'll call them. They're not curves though. They're not curvy. So I'll call them spline. Fine. All right. So good for now. And this will be our output. Let's put it down there. And good enough. Next thing, I think we will start with a sweep. And so we need a sweep. So anyway, and we need a resampler of some sort. So just a normal resample. Let's put it on here. How does that look like with the point numbers? Good. We need that for the sweep here. So let's get that in here as well. So now we'll start creating the operation that we needed or that we wanted to create. And all right, so sweep, let's go with the tube, and let's go with the columns like we did before with the ooh, these are bad. These are horrible. What is happening here? How can I clean this? So if I put a clean here, what happens? Does it clean anything? Is it cleaning anything? Yeah, these are horrible. Stretch or don't stretch. Okay, I'll check if that's something is happening on his end or in his station, and we'll see if it is or not. All right, so I'll pause, up, record, and hide that thing. Hello, everybody. Welcome back. So that is a normal result, it seems. It is part of the game. So what we'll do is a radius expansion. a little bit. Eventually, we will basically... Okay, what does this stretch do? What does it do? It stretches them out. So if I do like something like this, nothing happens. Okay, so we'll give it to 10. Number of columns, I don't want so many. So I'll go with, I don't know. 1 looks fine to me. I don't want so many cables here. Let's do 2 for now. And yeah, so the twists, what happens now if we introduce any type of twist, it will not be ideal. And just checking on my mic, just really quickly. Yeah, my mic works, so that's awesome. Okay, so sweep and then collision surface. So let's see where we could add our twists. Yeah, right there. So the problem with adding our twist here is it won't respect the same frequency. So I don't know if you can see this, people, but if I do a screenshot here, right, and we go into the screenshots thingy from Windows, and so if I start drawing, you'll see that this frequency is way bigger than this frequency, and that is inconsistent. And the way we could make it consistent is by getting the number of points and creating an attribute by that. So you already imagine we need a for each for that, like we did before. So for each loop that would work on the primitive level, so PR, or on the point, yeah, on the primitive level, and then we need some type of wrangle that says the number of points is equal to the point number, which is an attribute we will just create. And this attribute will just take all the numbers from this current line. So if it was like 400, it will, instead of having it in the spreadsheet as 1, 2, 3, 4, 5, it will count all of them, and it will make it will create a new attribute and will make an attribute for it. So it will be 5 in that certain instance, or in that certain go, or in that certain loop. So every time you hook a spline to it or a curve to it, it will calculate the number of points, and this will be taken then to the sweep, and it will create a twist that is respectable to the number of points. And this is how we can get a frequency that is equal everywhere. So let's work on that. It's a lot to explain. I think it's better to just work on it. So let's do a for each. Let's do primitive for now and see if it works. And one more thing we need is, what the heck is this? Height field mask clear? Who asked? Who are you? No, we don't need you. Okay. Good. A resample, and then the loop comes in between. Here we go. Be right back, off lunch and going back to some vellum work on my own. Okay. All right, buddy. Thanks for joining. I'll hit you up about the podcast very soon. Hopefully we can find a spot on a Friday or so. That's usual when we record. And hey, have a great lunch. I'll see you soon. Good. And so no worries. Cool. Awesome. Good. So we have a sweep, and then we would need a... What else would we need? We need a wrangle here. And that wrangle should theoretically give us the ability to get a new... okay, let's just review how we did it in the operation here with our first wrangle. Or is it like the established num points? All right, so we did at num.Pt.6 equals at num.Pt, which is... So at number of points will equal the number of point. And number of point is the one that comes with Houdini as an attribute within. And which one, you might ask? You don't see it on the spreadsheet. Well, in my understanding, it's this one, basically. So this 0, 1, 2, 3, 4, 5, 6, etc. is the num.Pt, if I'm not mistaken. Okay, so let's start with it. So at num.Pt.6, which is the one, either num.Pt.6 equal at num.Pt. Let's see what this would do now. And this has given us a numpts or numpt. Let's see, which is the new numpts. Okay, so that is the new number of points. So the one that comes with Houdini is the number point, which makes sense because it really goes into each number of that point. This is 0, 1, 2, 3, etc. And this is the one that we introduced. And so we can make it an integer to be sure about the value. Click away, and then now we have actually an actual 41, not a 41.1, not a 41.0, just a 41. And this would work best now because we will start referencing that into the number of full twists, I suppose. Okay, so the way we do it is like we did it a lot of times. We'll start with a point and we'll open it. And in the point here it says float point string surface node. So which node are we using? Is it the 0, the first one, or the 1, the second one? Because that's how math works. 1 is 0 and 1 is 2. That's the digit. And okay, so the first will be the string, which we are used to, will be 0. Float point number, it will be a float, and it will work with which point number. This is specifically asking us for the point number. We can go with 0 to start with the 0 point always, and string attribute, which will be our attribute name, which is numpts, I suppose, yes, and float index. What is the float index? The index I still don't quite get, honestly, but let's go with it. So it will be 0, comma 0, comma attribute, which is numpts from the wrangle itself. If someone can explain me the index, I'll be happy to learn more, of course. And what am I missing still? Let's see if we just expand it. And did I call it numpts? The wrangle? Oh, is it a float? That's why it's not working with it. 0.00 numpts. All right. We need to close that, dude. Yeah, let's close it. Here we go. And this is away. And now it's a proper expression, and it should tell us 41, which is exactly the same point number of that certain curve. We can check the numpts here. 41. Why did we choose point? Because we could have chosen the actual so this is a point attribute, so we're telling it look into the point attribute, or we could tell it look into the vertex attribute or primitive attribute. In this case it's still a point attribute. We could have promoted it to be a detailed attribute like we did with the other operation, but for now we just kept it in the point, so we used the point. Now I can take a breath. Wow, that's explaining a lot of things. Damn. I hope you can keep up with me. Okay, let's go. We have numpts, that's correct, good. Then what we can do is divide that now. So we can divide it by 10 or so we can get a frequency of some sort like that. I think an 8 would be good. Actually, the smaller the number, the worse it gets, right? So if I do 15, that's a frequency. Yeah, I actually want a very big frequency, like something like this, because cables are not usually so spinny. Is that a word? Okay, I hate that one. But for now, I can't really change that one. So what I'll do is find a nice frequency that would work. We can smoothen them later, but I just want to see like the null, the out of that loop. So we'll just put one of those in here and get the just gonna call it out loop. What should we call this? Equal twists, equal frequency. Good. Let's check all of them. Now this is, if I look at it from this far, we have equal amount of we have equal amount of how to say spins, twists, in comparison to this here. Let's just clean everything. You can see it here. It's way smaller in this area, and now it's this. So wrangle, very simple way to do it. Add a loop, make it go through each one of them, calculate the number of points, and this is how I did it. We created a new attribute, called it number of points, and we took that from the numpty and we added the sweep to that by adding which type of attribute it is, point, detail, or per vertex or whatever. And then we added 0, so it starts from the input 0, then it does the hey, just want to congratulate you for the grind. I couldn't do this every day. Oh my god. Well, anger is a huge factor, if I may. Yeah, I got laid off, and so I got really angry, and now I decided to do this every day, and I was like, that's the only way to channel the anger, my friend. And so thanks for your lovely comment. I appreciate it. But yeah, anger is a really great motivator to keep going. Appreciate your input. Yeah, so yeah, we do Let's Learns, and those Let's Learns are like Let's Plays, but instead of what you watching me struggle through Dark Souls, you'll see me struggle through Houdini, which is way more struggling, but it's fun with other people, and you get to learn a new thing, and it's challenging. So yeah, hope you'll tune in and see you on the stream more often. All right, let's keep going. Good. Let's keep it going. I think an ad will play soon, so might take a break in a minute or so. Not a big deal, dude. We can get there. Yeah, good stuff. Let's keep it up then and learn some more. Yes, absolutely. I will just put this thing a bit bigger here, because if I'm not talking, I'm not talking, right? And y'all can see this thing, and I also would like to add one more graphic on this thing. All right, let me pause. The things that I just learned is, indeed, so we have a Vellum simulator, and like I said, I really hate these curves here. So one way to fix them, I've learned now from the workshop, is you could, for example, add a bit more points to them, and they will still look bad. But also, if you go to the sweep operation and go up to, yeah, disabling this, it should work better. And one more thing I've learned is, and I need to go back, I think, and just learn it a little bit again. Just give me a second. All right, so the other thing that I learned is orient along curve before it. So if we do an orient along curve here and just add it there, and yeah, that should fix some of the issues, as you can see here. Actually, most of the issues. Yeah, these are the annoying ones. And now hopefully we could stretch this thing a bit more in the twists. So maybe I could go with something like 35, and I won't have to worry about the edges. Yes, I could. That's awesome. 45. Yeah, let's do something like 100, where it's just spinning barely. Yeah, that is something from an art direction I'm looking to do. Did you set it to subdivide curves in the resample? That might also help. All right, so thank you for the advice. Let me check that out for you. Subdivide curves. All right, so subdivide curves. Let me check. To subdivide, maintain primitive order, resample by polygon edge, method, even length segment, measure along curve arc or along chord, treat polygon as subdivision curves. That's what you said. Okay. Ooh, yes, that looks pretty good. Yeah, my friend, you got it. But the thing is, I'm not sure now if it's too out of shape. Actually, no, it's not. All right. I think we got the solution. Thanks Thanks for dropping by. That's pretty cool from you. Thank you, my friend. All right. Now we learned a new thing, and I might just apply it as well on the other sweep because this is pretty good stuff. Let's do that and apply it into operation find shortest path, which basically should allow us to do the radius search and this sweep in the beginning. And if I put that one, if I give it a resample before, yeah, this is the resample, and I do, what is this one doing? So it's taking the original curve, then the first thing it's doing is sweeping it. So might not hurt to get a subdivision here and then hit it up with the sweep, which should eliminate those weird issues that we had before. Because before we had straight edges, and now we have these. And if I do radius search, a lower one, it's a better one than before. Yeah, that's a better one. Okay, we can look and see what this one is doing. We'll let it calculate. Let's double escape. Come on. Double escape. We don't need to look at it now. We only need to look at it in here. I'll wait for it. And okay. We have to do this manually. Let's view. What the heck? Okay, I'm gonna go all the way down here. Check this resample. All right. Wow, Houdini. Look, so cool, right? Look what we did, Houdini. That's awesome, right? So cool. Yeah, okay. And now we have the output, and now it's working. And if I just eliminated the problem we had before, right? If I do a 2 here, now we still have these weird issues. All right, but that's fine. At least we reached some type of fix for bigger scaling. I'm glad that we did. So we'll save that. And yeah, as an incremental save, we'll go to Grayson's chat and we'll delete that file and actually upload the new one. And yeah, they will check it out when they're awake again. That's cool. And yeah, let's keep it going, people. Yeah, we've learned this new thing. And we have copy to pass, copy to points. I'm so glad the chat helped me. That's so cool from you, John. Appreciate you a lot. Okay, orient along curve, and yeah, this thing is working. We did that, and what happens if it was without it though? No change. So I'll keep it now for now. And the next step is to do a group by range. So group by range for the pins, basically. And here we go, group by range. Awesome. First of all, by each attribute like that, we need to choose what is the group type, and we'll put it a point, and then we'll call those pins, because those will be the pins where they will be fixed or fixated. I'll put back our points with the point numbers, and just in order to be able to see what is happening here. And so number one thing is we will go with union with existing, or intersect with existing, or subtract with from existing. Okay, let's see. We'll probably need the start to be 1, the end to be 1, but we also need the connectivity to work differently. And that's something I was trying to do yesterday with the pipes. If you remember, I was trying to do that using different loop methods and whatever, but actually it's as simple as clicking affect disconnected geometry. And if we look now, we view that node, you see that it's selecting, and I should actually allow it to select the inverse of that, which will be invert range right there. And now it's selecting the first and end point of each and every curve. And that is something we were looking into doing last time we were working on this, and I will take an example and demonstrate it for you why we were looking forward to fix this. And yeah, let's just get into it. So let's take that group by range, the exact same one, copy it, and go all the way to our what is it called, calculation. Nah, that's not the one. Find shortest, exactly. So guys, we have this path here, right? And we have this path here. The only problem between those is they are not connected to each other. And I was looking into a way to make them connected and fuse their last ends, but I couldn't find a way to do it. But now we have the solution. So I copied the group by range in here, right? And we'll put it in there. And now we see that it is basically taking the ends and the starts of each and every point from this side. So I will call this one ends green. Actually, it's tips. Tip green, and this actually it's tips, tips green, and this will be tips purple, tips purple, purple. Good. And so we have the tips group now from each one of them. What we will do is find a way to merge them both without losing the group, which is just a normal merge, and then we'll get to the fuse. Let's see if we could do that without losing everything in the world. So group tips green, target group tips purple, and now we should, if I increase that to a 10, it shouldn't really affect much because it is actually affecting a lot. And maybe it is too big, so 0. All right, wait, 1, and hopefully this had merged them. It seems like it did. It seemed like it had merged them. So one way to find out is the point number. Points 119 and here 112. That had deleted a couple of points, which is a success for us. Let's see if that works. So let's see. Fuse, merge, good. Then orient along curve, awesome. Let's just look at the HDA itself without looking into these numbers. Yeah, we have double entry here, and these are gone. Which is not a good thing, obviously, but that's what the fuse does. I can't fix that problem, so if anybody knows how to fix that problem without effing the normals or anything else, like, this is not good at all, because before we had this result, which is also not good at all, but it was better than nothing. But anyway, double entry is something I think we cannot avoid for now, unless I don't fuse snapped, and this would not fuse them, which is not what we're looking for anyway. I don't know how I could do it without losing a lot of the normal values, I guess, which are not even showing at the moment, but for some reason the fuse isn't just not working. So yeah, bypass that. It's experimental anyway. I will also bypass those, and since it's experimental, bypassing, and yeah, we'll save it and send it over for feedback. Good stuff. Let me do that. Okay, 999. Here it is. That one. Yeah, let's upload this one. Good. Awesome stuff. Let's go and continue from here. And yeah, the thing keeps on going. We'll go with the, let's keep going with the simulation for now. We'll add a vellum sim, obviously. Trying the fuse, don't recompute normals. Okay, let me try that for you. I hope it will work out. Thanks for that tip. Okay, let's go in here, and in the fuse, let's allow the groups again. Boom, boom, and here, and we'll get to don't compute normals, recompute affected normals. All right, let's see the final results. Oh, okay, yeah, we still have this problem here, and if we recompute, it doesn't change much, at least on that end. Here as well is a problem, as you can see. Well, maybe it's not snapping that well. Let's do a 3. Let's do a 5. Still not snapping. Maybe I missed the point. I don't know to fix that one, but it's fine for now. it's fair enough, I guess, that it's not working. Otherwise, I don't know what to do with it. Maybe this method is invalid. I really don't know for now. But yeah, we'll see what Grayson says. We'll continue with the Vellum feedback. But thanks for the tip. Appreciate it. And yeah, if you have more, I will try them as well on the stream. Don't worry about it. Just hit me up. No worries. Good stuff. All right. So we have these noodles and we need to get them to work. All right. So course, I'll be watching, as you may know already. So yeah, I might go silent. So I'll be right back.
After our resample. There we go. Cool. So now I don't like how me, but I guess it's not the biggest deal in the world. We're just going to sim these out anyways. So let's create a group by range after this so that we can group. And oh, there's going to be a group by range. Whoop. By range. Plug this in. Okay. Set this to points. Name it pins.
Maybe you have some nodes below with recomputed normals.
Disconnected geometry separately. We'll set the start and end to 1.
Let's look at it. That's a good idea. That's actually a good way to look at it. So that's the node we were working with. This is the okay. Wait, you can't see anything. Okay, so yeah, that's the operation. And if I may show you, like, that is the fuse that was right there. So I will enable it back again. I enable the groups. All right, that's good. So if I go here and it goes into a merge and then into a switch and then into an orient along curve. Should I bypass that and check the result? Maybe that is why this is happening. Bypass that, then we lose every single thing. And yeah, I think that is the reason why this is happening, if I'm not mistaken. But I mean, one can take the fuse out, so basically bypass it from here and maybe enable it here. Is that what you're saying? No, that also doesn't work. Unfortunately, okay, that's good though. Good to know. So yeah, whenever the orient along curve is, is affected or is there, okay, guys, I'm just gonna pause. Try to get the Vellum solver now in, and let me just do that. No, sorry. Okay, Vellum solver. Let's get to the Vellum solver. Okay. Yeah, that's proper. And we don't need that. So we will do a hair, so Vellum hair, basically, and change its main method. I think so, yeah. And we also need that input inside, which is saying a constraint geometry, which is the pins. Okay, so instead of hair, we'll take a string, and we can now go down to the pin points and actually add the pins. And we're close now, closer than ever. So yeah, we'll go learn some more and we'll be working, people. We'll view it first and give our timeline a bit more time, like 80 maybe, and play it. So we'll calculate, I guess. Ooh, neat. Yeah, that's pretty cool. We'll probably need to stretch it less, but this is pretty cool. That's pretty cool. Yeah, we need stronger, much. Oh, we also need some type of glue on the top points as well, I could see. All right, yeah, so let's learn. And the more we learn, the better we get anyway. And so we're back at it. We should make these cables, we should add collision to them. And if I can just view that one here, if I just hover over it. Okay, we should just hit escape, I guess, and view something else in between. If I hover over this, it will say collision geometry, as you can see. So if I basically select these two and put them a bit down there, and then I can take the final geo from here, which is not connected yet. Boom. And we'll just drag it down, like right into here, and we just take it as a collision. This should now add the cables. It should add all the geometry from the pipes as... Ooh, why do we have such a weird purple stuff here? Okay, let me check. Do view this one, or maybe view this one. Okay, and then it goes to the copy to points. Okay. I don't want to transfer the color. Not at all. Oh, it's because of we disabled the visualizer, right? I just wanted to have the same color everywhere for now. And yeah, I think I would prefer that for now. For the time being. Okay, simulation vellum, and we have our collision. So what I could do is view our strings and just template the geometry just to see, yo, is this thing bigger? Are the cables bigger? And just a quick check on my mic. Sometimes it just stops working. Yeah, it is working. Awesome. So yeah, we will make sure if the cables are bigger than the geometry itself, so it doesn't collide. It is not the case because it is colliding. So this easy fix is to increase the radius a little more. Like this should be sufficient now to keep it away from any trouble. But it could have trouble here as well. We're just gonna view it. Should be okay. All right, so now this should work as a collision, the geometry itself, and we have to cook it again. So, and we press space again. All right, now we have to view it first. View the Vellum solver right there and play. Ooh, it's looking good. All right. Output here will look like if I merge both. And this is just for viewing purposes right now. Let's merge both, and this is how we're looking like right now. Excuse me, my nose is stuffed. I'll be right back to the recording. Here we go. And yeah, this is how it's looking like right now. We can still play with the stretches, but I quite like that. Honestly, this is looking pretty wild and pretty nice. Yeah. Oh my god, this is actually pretty nice, man. Let's see what we can do next. We're probably gonna be able to play with the amount of stretching that is currently in place. So we can take this to 0.1 as an example and view the solver again and rebake this or recook this, and this should make them hang a bit less. Not really. Doesn't seem to be the case. I totally forgot what those were for. But I know it's right there. So if I increase the stiffness, which should make them stiff. So the stiffer they are, the more like iron they are. Cables are usually stiff. They don't hang that much. Let's try a 2 on here. Actually, a 2 won't help much. We're probably going to play with those. Let's see. We could just experiment with this a little bit just to understand what are we dealing with. Is this a bit like cables or is this more like noodles? Yeah, that's more like noodles. So the stiffness didn't really work here. And excuse me again, I'm gonna have to sniff. Okay, stiffness needs to be less, I guess. And we'll just bring it back to 1. Let's see how that looks like. We're just trying to learn here and see, do we have it more stiff or do we have it more like cheese? It's weird because I don't see any difference, honestly. So we'll just turn it back to the normal value for now. I think the dumping here is doing a lot of work, a lot of the heavy lifting. Let's see back again then. And bake it back again. Yeah, that's way too cheesy. So yeah, okay. So we'll make it feel like cables more. And that is by bringing it way down like this, for example. And view it back again. And this is controlling the stretching value. Yeah. And if I do a bit of scaling on that, so say, actually we can't do that. Something even less, that's a bit too less. Let's do 1 and 0.5 here. That's half of the value we're currently working with. Let's see how that will work. Yeah, these feel a bit more like cables. And I think we need to increase the radius a tiny bit. So let's do that right now with the sweep, and let's turn it on. Is that the case? Okay, we still don't know, but fine for now. I will probably play with those a little bit more. Like, what is the total opposite of this? Just wondering. This would be cheese. Okay, that's what you're getting. All right, so that's a total opposite. And let's do 10 on this one then. And check it out back again. So this should make it stiffer. But there is really not much difference. No matter how much we take this value up, it's still the same. Rest length scale, let's check that out. I think that would make it pull on each other. Oh, now it's weird. It's doing other stuff. Is that the length of the actual length of the stretching? So if I put it on less, would it like pull each other up now? Yeah, that's pulling each other. All right, so this is like the to increase the sub steps, I would have to do that. That's very true. Let me check. That is in the solver, if I'm not mistaken, right? Sub step. Here we go. Sub step. If this was increased to 200, for example, it will take more time, first of all, and it would. Whoa, it's way more time. Okay. Escape here. Let's do a 50. I think 200 is very extreme. Okay, wait a second. Let's go back to frame 0 and let's do a 20, for example. Let's see what that would do. All right, that will take a lot of time. And maybe we just add like an 8 sub steps. And I think I went a bit too extreme with it. Let's go again. And let's see what that would do. Set it to 3 or 4. All right, so good. Yeah, thanks for letting me know. We'll go with 3 for now because I know my PC is not as strong. So this would do... hey, it's again a scammer. So we'll hide the alert and delete their message. Okay, so many scammers today. All right, but the thing that I don't get, would it have to render 4 times now or 3 times for it to work? Because why else is it taking a long time now, even though it's rendered? I think it has to do a 3rd one, and then we're good. I'm not sure. Let's see if that's the case. But it is slower, definitely slower. Let's see. I'm not aware of what the substep is doing. Yeah, I don't think this would work. So let's go with 2 just to see and play. Let's render it. Or cook it, sorry. I'm using the wrong terms, left and right. Let's see. And the second one. Vellum Sims, yes. Hey, what does a substep do and why does it slow down everything, dude? I wonder. But you will have a long length, maybe reduce a bit the rest length scale. All right, so you're mentioning rest length scale. Reduce that one. I also thought so. Maybe that's also too much. Let's see. Yeah, let's cook that back again. And now it's pulling on itself. Yeah, that's fine. It's okay. That's probably the result we want to. So a substep inserts a frame step in between frames. So substep of 2 adds another sim frame in between frames. Okay. It's essentially doubling your sim time. Okay. And so if why does the substep 1 work so well with the playback? So for example, now we cooked until 80 frames, and then, wait a second. What is not baking here? Why is it deleting everything? Are we running out of RAM or something? So if I do like 40 here, would that playback a bit easier? Yeah. So we're running out of space or something, right? And when we add a substep, we have to calculate that it won't be able to play back that time as well as it did, right? You're just running out of sim memory. Here you go. In your Vellum sim options, you can increase the memory. Vellum sim options, cache memory in megabytes. This would go, I suppose, to the RAM, correct? Or would it go to the or do you think it would go to the desk, basically, is what I'm trying to ask. Correct, and RAM. Okay, so let's see how much RAM I have left. That's why they take the PCs with the big RAMs, huh? All right, so RAM is doing fine, actually. We're doing okay-ish. Let's see. We have how many free? Committed, available 52. So we would take a bit bigger RAM value here. So this is around 5 gigabytes. We can do 15 gigabytes, for example. And let's see how that would work with the side step. Yeah, feel free to just double it and you should be okay. Nice. Yes. All right, cool. Thanks for the tips, guys. I appreciate that. Good. So this would simulate now on dubstep 2. on substep. Okay. And if I do substep 3, we should have enough memory to work with it. So dumping. Let's see. Okay, focus back again, Jack, in the solver right there. If I add a 3 in there, it should actually now do another one, and let's see if it would save it with the current RAM setup. No, it can't. That would be too much. It's like tripling the size, basically. Yeah. So that, oh, actually it is doing it. Awesome. Uh-huh. I like how it's polling on itself. Let's see. Let's take the final result anyway, because we won't be animating this in Unreal. We'll just take the cooked result already and just look at it a little bit. Look at it in different ways. From far, it looks okay. It's fine. Constraint iteration. So have a look at what happens if you use substep 1 and increase constraint iteration to, say, 500. Constraint iteration are very cheap way to increasing the fidelity of your sim without extra sim step with your substep. The reason I told you to increase the substep is to get the stiffness. Yeah, I got you. Don't worry. Okay, so let's work on that then. Let's see how that would work. Feature creature said, what happens if you use substep increase constraint iteration to, say, constraint iteration, correct? Okay, so this one you set 500, which would do what exactly? Let's go substep 1. It will increase the fidelity you set. All right, so let's see how that would work. Interesting. That's actually pretty fast to render. And yeah, but here it did some weird stuff, right? Or is this from before? So every point is technically a constraint. Yeah, okay. All right, and there is a way to visualize that, right? If I like visualize the stuff here, we will start seeing the constraints, correct? Yeah. It's cheaper than more substeps. Okay, it's going back over your points, making sure the values are correct. Okay, it's cheaper than more substeps. 2 substep is probably the most substep I will ever use. Interesting. And use the constraints iteration to tidy up stiffness. And use the constraint iterations to tidy up stiffness. Okay. Okay, so basically, if I would take now the stiffness or sorry, the constraint iteration up to, I don't know, 1,000, would that make it more stiff, you're saying? All right, so let's look at it. Yeah, now it's definitely taking a lot of time, but that's fine. It's calculating. And we do have different results, but I can't yet like fish out the reason. Let's see, or what happened differently. Yeah, the stiffness is definitely there, dude. Yeah, I totally get it. This is noodles. The other one is more like something else. Okay, 500. And let's go back. You can see it takes longer, but it definitely goes through each and every point to reassure the data that we're given. Interesting. So we have duplicating. Oh, okay, so, and that makes sense, man. Okay, so let's see what else did you... So every point is technically constrained. Good. To stop step is probably the most sub-step, yes, and use constraint iteration, exactly. What's interesting about Vellum is it's also going to behave differently depending on the scale of your input mesh too. It's also going to behave differently. Okay. But that makes sense, right? So if we scale this up, now I'll go and look at this. Scale it up to 10. That's too big, right? But let's just look at it. And let's see what that would do. Let's go. Yeah, this is behaving way differently, as you have already suggested. I guess one way to do that and keep it syncing with it is if I take the value of the scale and I hook it to either the constraint iteration or to the vellum hair somewhere, so that it would increase stiffness, or it would even reduce the points it's working with the resample, for example. That way we could sync the scale with everything else. Sorry, I mean the scale of the hairs themselves. Okay, but yes, you could do that. All right, so yeah, what I will do now is go back to the course and learn what else is there to be done. It's super informative that you guys have taught me how to do this. That's super cool. And it's so satisfying to see it work. That's really awesome. And now I totally understand it a bit more, at least. So yeah, you said the best setups, like put your put your substep to 2 and play around with the constant iteration to get the perfect stiffness that you're looking for. Let's see. And the sub step right now is definitely working around with the stiffness. But this is awesome. I really like the results so far. But why does it have to calculate? So a sub step has to calculate twice at least, and then it would cook it, right? And then we're talking, and then we could replay it as such. And I feel like these are too stiff for now. I would like each one of them to act a bit differently, and the only way to do that is to go here and just get like a 9.5 maybe, which would, you know, loosen up a bit. And we'll read your comment. And you're saying John CC said, or Johan CC, sorry, decreasing the point on the resample also helps. Okay, on the resample, yeah, because you have less stuff to calculate with, right? Substep 2 and constraint iteration, no more than 1,000. You got this. Thanks. It starts to have a very diminishing result. Yeah, returns. Sorry, exactly. 2 sim passes per frame with substep 2. Awesome. Yeah, I get it. Yeah, this is way too loose for me for my test. So I will go with like maybe 0.9 on this one, and I will go with the resample to a value of like 0.1, I suppose. 0.1 should do the job, and this will, like Johan CC told me on YouTube, this should reduce the time amount it takes. And let's see if that's true. Thanks for the tips, guys. Appreciate it. Okay. Then we'll wait for it to calculate, and boom. Yeah, that definitely took less time. We can smoothen these out later, I guess, because we're only looking for to bake like frame 40, for example, and then we have that baked in Unreal, and then everything would look Gucci, basically. All right, so you say, hey, Johan Che, hello from Korea. Nice to have you here, my friend. Is this your first time? And yeah, it's amazing to have you here, my friend. So what is happening here, dude? This is a bit weird here. Don't know exactly what is happening. I don't like the results. Not a big fan. I think also the sweep here is going a bit too extreme. So we'll go to something like 1.5 or 1.5. 0.15 basically is what I'm trying to say. And let's go back and play that again. And let's look at it as it's getting created. Yeah, hello from Korea. Nice to have you here. And yeah, I hope you enjoy your stay. If you have any tips or if you're learning Houdini from the beginning, let me know a little bit about you and what brought you to the stream. Nice to have you here, nevertheless. And I think for cables, these are a bit too loose, right? But I mean, it depends on the art style you're looking for, right? I kind of like that. I like that feeling. I would probably make him a bit stiffer. So we'll go, let's see, damping ratio. What would that do again? I think I forgot. Let's try 0.008 on this one. Go back and play it again. And this should lessen the stretch, I guess. And yeah, it is a bit less, isn't it? I mean, I do still like this, but I wish they were, I mean, one way to do it, damping ratio is what a module of energy is lost per frame. What percentage of energy is lost per frame? What percentage of energy? All right, so there's energy. I didn't know about the energy part, but it makes sense that it would have. So per frame, it's losing 0.008 energy per frame. And that is a way to. All right, I'm just going to go to the extreme of that, right? So it should lose a 0.1% each frame. And this would be actually dramatic right now, right? I just jumped into HDA realm of UE5, so pretty much noob in terms of GA. Well, lucky, it's your lucky day because I also started 42 days ago and I had zero knowledge about anything. Thankfully, I jumped into DoubleJump Academy's workshop, Houdini for Games and Unreal Engine, which will help you a lot if you're willing to learn that thing. If you want to reach out and ask some questions about some stuff, I'll also include the Discord link to you so you can reach out directly to me and with your question later on. But yeah, we also documented our process so far in attending the workshop, and it's been great. We've learned tons of things. I also interviewed the mentor on my podcast. You could check that out as well. It's called The Generalist. I also included the stuff on YouTube. All right, so Feature Creature says another nice cheap way to cheat that is to click on your solver to the Forces tab and add a velocity damping of 0.50 max. Okay, so let's see what that would do. So basically I increased the energy loss per frame, and now we're getting results like these. Feature Creatures, what is like the best way to, other than screenshots, of course, like I guess screenshots are great, but what is the best way to like compare the simulations from before? I'll take a screenshot right now because that's the only method I know, and I'll probably get a pure ref in here. And that's probably the best way anyway. Here we go. Remind me later. Okay, let's bring that pure ref in here. And yes, let's get that thing down there. Awesome stuff. What brought you to HDA, John? Because I'm interested in becoming a technical artist. Screenshots. Cool. All right, so let's see what the other thing does. I just want to try to like engrave that knowledge of the damping ratio. So this is 0.1 damping ratio. I'll go with like the value we had before, 0.001. and just have it cook again, and then I will go with your method, feature creatures. Nice to have you here. Nice to have you here, definitely. I'll just close this window, let it cook for now. I know it's satisfactory to watch the cook, but I will just add a note here. I say, wait, N click shouldn't be N click or Control N. And we'll just say damping. Oh, look at that color. Damping ratio. I don't know, 0.1. That should make it lose 0.1 per frame. And right now, frame 40. So let's just compare it from here. So this is with value. I mean, we see difference in this area, right? Can I draw on this thing? I remember I could draw, but I should probably get a pen or something. Yeah, it doesn't matter for now. In this area here, we have better. I like this better than what we have here, although we made it lose energy. So basically, feature creatures. A question to you. So when we have made it lose more energy, we kind of skipped through the simulation itself, right? Because if it was losing energy in 0.001, that means it was losing energy slowly. And when we fasten that up, that means we get better cook time in Unreal if we want to cook frame 40 always, all the time. Because we would get the lost energy of frame 120 instead, right? Does that make sense? I'm not sure if that's a proper understanding of this thing. But yeah, I'll continue nevertheless. We'll go through your another nice cheap way to cheat that is to click on Solver to the Forces tab. I'm just going to take a screenshot of this one too. And say, yo, that was damping ratio 0.00001. All right, that's awesome. Now let's go compare it to something else. So we'll turn this back to 0.1 basically. And why is this always on top? I don't want it. I don't like it to be always on top. How to change that mode? No, thank you. All right, so now it's not always on top. You say it makes sense, but not correct. No, sorry. The energy loss is more of a velocity loss per frame for that point. A higher damping ratio means more velocity loss per frame. Okay, think of moving through air versus moving through underwater. Okay, so basically, the one with the more damping ratio was like water, right? More damping equals more resistance. Resistance, air, or water. Yeah, and so. Yep, more damping, more resistance. That makes a lot of sense, honestly. All right, so I'm just gonna make another one. And this was like there is nothing in between, so it was not damping at all. But with water, actually, that's why it's floating, right? So here's the thing. Just to understand it, basically, I will go and take that thing up to a 1. Now it should be a lot of damping in between. So it will slow it down. It will feel like water. Ish. Let's see if that's correct, and that's a value of 1 basically. Let's see the look, okay, but that's, yeah, okay, so let's make it watery. Let's make it a lot. Okay, we can't go that far. That's fine. Yeah, more damping equals more resistant. Gotcha. I'm a junior FX artist who just started a career here in Korea. Awesome. And I'm interested in developing my skills to be an FXTD. Aren't you feature creatures? Aren't you an FXTD or something like that? I think I forgot your title. You mentioned it before. Maybe CFXTD. Oh, cool. All right. So here's your guy. We'll have him on the podcast very soon. All the things FX guys hate. Why is that though? Cool. Let's just keep it going. Yeah, damping ratio. Now we added a lot of resistance. I like the 0.1 result, honestly. But we kind of need it to be looking like there's air. So let's go with less, and let's go through the method. Feature creature gave us the cheap way to cheat that is to click on on your solver. All right, so on the solver, and do what? Do what? Click on your solver, and to the forces tab, and all right. So this is the forces, and then what? Add a velocity damping. Okay, this is basically the same thing, but could allow more results or different results. All right, let's see. So in here, we should go to the velocity, cheaper velocity damping, to the forces tab and add a velocity damping. Okay. Velocity damping of, all right, ground static scale, ground dynamic scale, dynamic scale. Let's see where we can find this gravity. Built-in wind, built-in wind, sorry. Built-in wind speed, built-in wind drag, velocity damping right there. So if I take this thing up to a 50, like you mentioned, which won't be working because of reasons. Okay, let's see. How would that look? Now we added a lot of velocity damping, and this would do this floating feeling. Yeah. Awesome. Cool. That's good to know, man. It's good to know. And if I do 0.5, this would look a bit different again. And let's cook it. They've normalized it. It seems like it. But I love this. Like, there's a lot of things to go through. That's awesome. Cool. Yeah. Go back to 0 for this one. We don't want too much resistance. We just want air resistance. But that's it. That's about it, though. Nothing else. Okay, good. Then let's learn a couple of new tricks. So I will be watching. And yeah, we'll go to the Let's Learn tab and overlay. And yeah, let's keep it going. We'll pause the recording. Oops. Let's play a bit with the friction, which is found under forces. Good thing we're already here. Let's add that. So friction, static threshold right there. So if I take that to an extreme one, like 10, we will end up with a probably not a wanted result, but it will do something like, let's see, something like, what is happening here? Let's see. What was the difference now? Do we have more of them stuck on the... Okay, so here's what I'm gonna do. I'll take the sweep and go down right here and increase this to 50 so we have more loops around our cables. All right, stop. Okay, they'll go with 20 and let's loop it. Okay, go back and go again. So the friction is like allowing it to stick together as such in here, I think. And if I loosen it up, yeah, you see it's all right. So let's see what that means. If I go now down here and go with this value of 0.2, I bet that this here will go down. Let's go all the way back and view it back again. So what I'm guessing is happening, I mean, we definitely have a different result, but what I'm guessing is happening here is our radius is not as big as we would like it to be. And let's get to sweep and increase our radius a little bit. So something like 85 on this one. And we have to re-cook this one and go. Yeah, and now we have a bit more space for it to play around, basically. Yeah, and the spins are creating more dangling parts. is the word I'm looking for. And I would love to see more of this, right? More of them being on the or around the actual what is it called? The actual pipe, basically. This is awesome. Okay, so let's increase the friction again back to 10 just to see the difference, and I'll take a screenshot like feature creatures had actually advised us to do. Cool, and we'll go back to the pure ref, and now we do a screenshot here with friction on, friction, okay, damn it, Control N. Friction equals 10. Actually, no, 0.2. 0.2, and the next one will be friction equals 10, basically. All right. Nice, man. Industry term for the screenshot collection you have is wedging. Cool. Yeah, because it's like wedges, I guess. Because you have like, hey, Sprava. Nice to see you here. Yeah, we're doing some sim, and finally, feature creatures is not bored. Yeah, we have more. Today's stream is very more entertaining for featured creatures, so he can do his job and do his job. So he can does his job and watch his job getting learned, I guess. So cool, man. Okay, let's play. This is friction on 10, so we'll have, but I don't quite get the concept of friction, because friction should be, you know, so there is more friction, that means it will stop it. So right now we're saying that each point has more friction. That means it's not stiffer, but it's less likely to move through things. So the least of a friction, the more wet it is. Like if I could imagine, imagine having loop on it. And if you have loop on it, which is 0, if you have loops on the cables, then it's a wet environment or oily environment even. And this should allow for more movement, I guess. And this is like noodles with water and oil, basically. There's a lubricant in there that allows it to move around the surface. And dried noodles will be, I don't know, 1. So they won't be moving around it. Yes, you say... It's just a way to explain it, I guess. So, yeah, exactly, you said. All right, cool. Oh, did I go up? Oh, you say lower friction equals less movement on your collision. Okay, that's what I thought. I thought the collision would also be playing parts there. Okay, so we kind of want to have some type of friction, because cables are quite factory. I don't know. They have frictions on them, because their surface is not like, if you hold a cable, network cable, whatever, and you go through it like with your hand, it's not gonna slide like a noodle out of the water. It's gonna be there will be some type of friction. I guess that's what I'm trying to get to here. Okay, this still feel a bit noodly to me, so we'll go with something like 3.5, and let's see how that would look like. Rough, yes, yeah, that's the word. Gotcha. Rough is the word, definitely. Take a cable, HDMI cable, whatever it is, and just go through it. Like if I take this cable, it's not... the opposite of rough is what? Smooth. It's not smooth, it's rough. So it has some friction. So yeah, I'm trying to get that. Maybe we add some more stiffness. Yeah, that's more cable-y, dude. We're getting there. We're getting there, definitely. Awesome. Cool stuff. We're getting there, people. We learned something new. Okay. I like it. Let's see what the next steps are during the course, during the workshop. So we'll go back to watching, and yeah, let's get back to it. Here we go.
However,
I'll be uploading the YouTube video, and the one from yesterday as well. We did a lot of fixes. Shout out to Feature Creatures, and shout out to Johan CC, and to the new people who joined, John Che, and as always, Brava, thank you so much for being here every single day. Elgato was not here today. totally fine. We're probably gonna have them tomorrow. All right, people, I love the support, and thank you so much. If you haven't follow me now. I appreciate it. What we do is a Let's Learn content, which is similar to Let's Play, but instead of you seeing me struggle through Dark Souls, you see me struggle through Houdini, which is way more satisfying to see. All right, everybody, thanks for watching, and I see you tomorrow. Bye.